Welcome to lesson 3.2, angles formed by parallel lines and transversals. In this lesson, we'll be looking at the corresponding angles postulate, the alternate interior angles theorem, and the alternate exterior angles theorem, and the same side interior angles theorem, and how they are applied to solve problems or to justify steps in proofs. In a separate video, we will actually prove, or should have already proven, alternate interior and alternate exterior and same side interior angles theorems. The learning targets for this lesson are to be able to prove and use theorems about angles formed by parallel lines and a transversal. The corresponding angles theorem says, or postulate, it's not a theorem, it's a postulate, it's one of the things Euclid had to assume true to be able to prove the others, that if two lines are intersected by a transversal, I'm going to put that in quotes right now because that's how all of these are going to start. If two lines are intersected by a transversal. If two lines are intersected by a transversal. For corresponding angles, which we know there are four sets in this picture, 4 and 8, 3 and 7, 1 and 5, 2 and 6, the corresponding angles will be congruent. So in this particular problem, angles 4, because these lines are given as parallel, that the transversal intersects, 4 and 8 will be congruent, 2 and 6 will be congruent, 1 and 5 will be congruent, 3 and 7 will be congruent. And we don't have to prove it because it's a postulate. In proofs that I write, you will see the abbreviation CAP for abbreviating corresponding angles postulate, much like vertical angles is VA and then theorem. The P stands for postulate. Sometimes people write CA post, so they don't forget that that is the one that is a postulate. We do not have to prove that one. For alternate interior angles, in that case angles 3 and angle 6, angle 4 and angle 5, if the two lines intersected by the transversal, if it's two parallel lines, sorry, let's make sure to insert that it has to be two parallel lines intersected by a transversal for all four of these things to be true. If two parallel lines are intersected by a transversal, then alternate interior angles are congruent. This is a theorem. We call it the AIA theorem when we're abbreviating it in proofs. Alternate exterior angles theorem says again, if two parallel lines are intersected by a transversal, then alternate exterior angles are congruent. We abbreviate this AEA theorem. And lastly, we have same side interior angle theorem. If two parallel lines are intersected by a transversal, then same side interior angles. Let's look. The alternate interior, you can see we're congruent. Those are both obtuse. These were both in acute. If you look at same side interior, though, one's obtuse and one's acute. They're not going to be congruent, and you may have guessed it. Look, angle 8 and angle 4 are congruent, right? What's true about 8 and 6? They're a linear pair, so they're going to be supplementary. Well, if 8 and 6 are supplementary and 8 and 4 are congruent, then 4 and 6 are also going to be supplementary. So same side interior angles will be supplementary. This is the SSIA, same side interior angle theorem. So these are what this postulate and these three theorems say. And we should have at some point done this and proven these. If not, we will be proving these three. So let's take a look at how we're going to, wow, I didn't know it did that, sorry. How we're going to use this. We have to explain our reasoning with a postulate or theorem. They've given us that angle 3 is 97 degrees. So I'm going to put a 97 degrees right there. So that means, hold on one second. All right, we're looking at angle 5. We see angle 3 is 97. And here's the vertex for angle 3. right here, and angle 5 is here. Their relationship is that they are alternate interior angles. We know that alternate interior angles are congruent by the alternate interior angle theorem. Well, since they're supposed to be congruent, that means that angle 3 and 5 have the same measure. So the measure of angle 5 is also 97 degrees. Next, we look at angle 6. Angle 6 is on the same side of transversal P with angle 3. They are same side interior angles. So 3 and 6 are same side interior angles, which are supplementary by the same side interior angle theorem. So this means that since that's 97, the measure of angle 6 is 180 minus 97. Which is 83 degrees. Measure of angle 6 equals 83 degrees. Angle 11. With angle 3, it has a relationship, but we also know 5 and 6 now, so we could have used those relationships also. With angle 3, angle 11 is on the outside. So they're both on transversal M. Angle 11 is on the outside, angle 3 is on the inside. They actually make the letter F, so 3 and 11 are corresponding, and corresponding angles are congruent by the corresponding angle's postulate. So since A is 97, the measure of angle 11 will also be, or since 3 is 97, angle 11 will also be 97. And lastly, we have angle 10. Well, we know 11 is 97, and angle 11 and 10 are a linear pair. Linear pairs are supplementary by the linear pair theorem. That doesn't require parallel lines. The linear pair theorem works for all linear pairs whether or not there are parallel lines. Vertical angle theorem works for all vertical angles whether or not there are parallel lines. Well, since 11 is 97, 10 is 180 minus 97, so the measure of angle 10 is 83 degrees also. Now we're going to be putting these geometric concepts. Notice all of them have congruency except for same side interior. Everyone already knows linear pairs are supplementary by the linear pair theorem. The only other set of angles we have at this point that are supplementary are same side interior angles when we're looking at a picture of parallel lines cut by a transversal. The rest of the sets are congruent. So we're asked to find the value of each variable and explain our reasoning to set up each equation. They don't give us angle names. Normally we'd start with angle names, and then after saying things are congruent or supplementary, then we would, we would write our equations. But we're not doing a formal proof, so I'm not worrying about it. This angle right here and this angle right here make a letter C. That means that they are same side interior angles. And we know same side interior angles are supplementary by the same side interior angle theorem. So if they had names, we would say this angle and this angle are supplementary, and then next we'd say that that means they add to 180 by definition of supplementary, and then we'd plug in our expressions. But they don't have names, so we're just going to write our equation. We were only asked to justify how we're going to set up our equation. We weren't asked to do a formal proof. So these add up to 180. This is 44x plus 4 equals 180 once we've combined like terms, and it's not a proof, so I don't need to justify every step. 180 minus 4 is 176. 44x equals 176. Divide by 44x is 4. We were only asked to find the value of the variable, so I don't need to go back and plug it in unless I want to verify that, in fact, the two angles do add to 180 degrees, that I didn't make an algebra error. For letter B, look at the types of angles they are. Think about, hey, look, we have parallel lines, so something's going to be true about those angles. Hopefully you identified them correctly as alternate exterior angles. And alternate exterior angles, when we have parallel lines, will be congruent by the alternate exterior angle theorem. So we can now say that 12x plus 17 equals 14x minus 1, or negative 1 plus 14x. This isn't a proof, so I just needed my first statement with a reason why to set up my equation. Now I can solve. I'm going to move the 12 over here by subtracting. I'm going to add the 1 to both sides, and now I'm going to divide by 2. X is 9. Since we were only asked to find the value of the variable, we're done with this problem. The next side is a little more complicated. I'm going to ask you to look very carefully at these parallel lines. Yes, that's a triangle, but we're going to kind of ignore the triangle and just focus on the transversal where the angles touch. See if you can set up a system of equations to solve that problem. And then do the same thing for D, and we'll look at those in just a second. For this problem, these two angles right here, actually there's 3 equations I could get from this. These two form a linear pair, so you could say this one plus this one adds to 180 degrees. Same thing with these. These form same side interior angles. So by the same side interior angle theorem, knowing that they're going to be supplementary, I can say 4x plus 10 plus 6y minus 4 equals 180. That's one of 3 possible equations. Using the linear pair theorem is another way. Again, that doesn't say they add to 180. It says it's supplementary, but we're not writing a proof right now. These two could be made to add to 180. 5x minus 5 plus 6y minus 4 equals 180. There is a third system of equation, or set of equation that I can generate, and that is if I look at this whole transversal and this top angle and this one. They are under the letter F. It's upside down, but they're under the letter F. So those two are actually equal. 5x minus 5 equals 4x plus 10. And that's by the corresponding angles postulate, which says that they're congruent. And since they're congruent, I'm able to set them equal. 3 possible equations, all solvable. If I used these two, I would use elimination, because they're set up perfectly for elimination. If I used these two or these two, I would use substitution, because this one doesn't have a y variable. I could actually get my answer for x and plug it into those. I will go back and do that later, but for now, I'm just trying to make sure that you know how to set up the equations. All right. We have in this picture 3 parallel lines, not 1, not 2, but 3, and 2 different transversals, and the transversals are not parallel. So I can't just start setting a bunch of stuff equal. I gotta follow the transversal. On the exterior of this parallel line, I have 125, and on the exterior of this parallel line, I have 25x plus 5y. These are on alternate sides of this transversal, and they're on the exterior of those 2 parallel lines. So by alternate exterior angle theorem, those angles should be congruent. So 25x plus 5y should equal 125. For our other equation, we're going to follow this transversal. This one tends to be inside these 2 parallel lines. This one is outside, so I'm going to connect that transversal a little bit more. I see the letter F. So by the corresponding angles postulate, those 2 angles are congruent. 25x plus 4y equals 120. This system is set up perfectly for elimination. I will go back at the end and solve these for those of you who need to see those steps, but most of you don't. As long as you can set it up, you're already good at the algebra part. Take a moment to see if you can set up letters E and F. E and F. In letter E, these are alternate interior with the parallel lines. So, since alternate interior, and that's interior, not exterior, angles are congruent by the alternate interior angles theorem, 4x minus 14 equals 3x plus 12. You don't even need a system of equations. We only have one variable. You can quickly solve for x. And again, the directions were to find the answer for the variables, so I don't have to plug it back in. In letter F, there are 2 relationships to this 70 degrees. Angle 2 has the nicest relationship, and that they make the letter F, so those are corresponding angles. Since corresponding angles are congruent, angle 2, which is this expression right here, is equal to the 70 degrees by the corresponding angles postulate. 2x plus y equals 70 degrees. Angle 1, however, is not corresponding with the 70 degrees. When I trace those angles, They're both inside the parallel lines and they make the letter C. So those are same side interior. Same side interior angle theorem says that same side interior angles are supplementary. So angle 1 plus 70 will add to 180. So that means since angle 1 is 2x plus 2y, I need to add 70 to that to equal 180 for those angles to be supplementary. System you set up for letter F. For now, we're going to skip example 3 because I go through a whole separate proof system, hopefully in class, but if not, I'll also have it by video, on how to set up and prove the different theorems that we've been using here. If you are good with this, you may stop the video here, you may try to solve, you can even fast forward to the end to check the answers to these problems. At this point, I'm going to go through and solve these, so those of you who want to solve the system and make sure you're good at that can be set. For this first one, I normally like elimination, but I'm going to use it for the other ones. So here I'm going to use substitution by subtracting 4x and adding 5 to get x is 15. Now that I know the value of x, I can plug it into this to solve, or the top one. 4 times 5 plus 10 plus 6y minus 4 equals 180. So that's 20 plus 10 minus 4 plus 6y equals 180. That's 30 minus 4, which is 26, plus 6y equals 180. 180 minus 26 is 154. Divided by 6, y is 25 2/3, or 25.6 repeated. For the other problem, the one on the upper right, I do need to use elimination. The 25x and 25x will cancel nicely if I just change the signs on this equation to minus, minus, and minus. So my x's are now gone. I have the variable y, 1y equals 5. Since y equals 5, I can plug that up here. 25x plus 5 by 5 is 25 equals 125. Subtract 25, 25x is 100. Divide by 25, x is 4. I now have the answer for both variables. For letter E, we don't have two variable system. I just have to solve for x. Subtract 3x from both sides. X minus 14 equals 12. Add 14 to both sides. X equals 26. And for this last system, first I'm going to subtract the 70. So my top equation was 2x plus y equals 70. My bottom equation becomes 2x plus 2y equals 110. The x's are already the same value, so if I just change the sign on one of the equations, I chose the top, this makes this y equals 110 minus 70, which is 40. Since y is 40, I can now plug that in up here. 2x plus 40 equals 70, so 2x equals 30. Divided by 2, x is 15. Our system has been solved. Have a great day.